Thank you so much for joining us today, both in person and those via live stream. I'm Melissa Milner. I'm one of the military fellows here at Watson. On behalf of the Watson Institute, the Climate Solutions Lab, and the Brown Military Fellows Program, we're grateful that you're joining us for what we expect will be a very informative conversation with Dr. Kate White. She's the Department of Defense Climate Resilience Program Director, and she's going to discuss how the U.S. Department of Defense is tackling the climate crisis. As you are all likely aware, today is Earth Day, and while we consider every day Earth Day, today does provide us an opportunity to reflect on the challenges facing our Earth and consider the steps we can take to reduce the risks of those challenges. Our agenda today is presentation with remarks from Dr. White, followed by a Q&A session moderated by Watson's Climate Solutions Lab Director, Dr. Jeff Colgan. We will then welcome you to join us for some refreshments after the event. Now I'm excited to introduce Dr. Kate White. As the Climate Resilience Program Director within the Office of the Assistant Secretary of Defense for Energy, Installations, and Environment, she serves as the Principal Advisor on policies, programs, and initiatives to enhance the climate resilience of Department of Defense military facilities and installations. She's a registered professional engineer since 1989, and Dr. White holds a BS, MS, and PhD in civil engineering. She has over 36 years of government service, 20 of which have been also included on a focus on changing climate. So without further ado, I'm pleased to welcome Dr. Kate White.
Thank you. Thanks, Melissa. And what we may do is, since it's more interesting, if you have a question while I'm talking, just raise your hand and ask a question. And I know this might be harder for the people with the mics, but I think it's just easier if you have a question than to wait till the end, write it down and wait till the end. So thanks for inviting me. I wear green for Earth Day with my Respect Your Mother Earth badge because it's really important to me. And what I'm going to talk about here is the fact that the Department of Defense takes climate change very seriously, right? It is really important for us. There's nothing that we do, more important to us than defending the American people. Then everything is impacted by climate change for the American people. And so the Secretary of Defense, that's a statement from him at the top, and at the bottom from the Deputy Secretary, Dr. Hicks. Climate change is the context for all future climate planning for national security. So the issue here that we face is that environmental conditions are just a basic form of military planning, and they affect every kind of decision making that we do. We have to understand the environment, and more so, we have to understand that the environment is changing in a very unpredictable way now that we're beyond the past envelope of climate that we were accustomed to. It's changing in ways that we don't quite understand, and some of these changes are subtle and some of them are not. Some of them happen quickly and some of them are slowly. But really, for instability, competition, and conflict, we have to pay attention to the climate, and we do. We train. The military constantly trains, and I think our ROTC students here definitely know that, but you can't train for combined operations, which is part of all the work that we do with our partner nations and allies, when the training facilities are flooded, and this is happening more and more, whether it's here or whether it's overseas. You can't adequately prepare for the future if you're constantly reacting to what's going on now. And this is an example here of fire. Support to civilian affairs, defense support to civilian affairs. Constantly, the Air Force is being pulled from reserve activities and readiness and training to be fighting fires. So they've moved from a fire season to a fire year. And while they're doing this, they're not doing the kind of training and readiness that they're expected to do, but they're also being exposed to hazards that they wouldn't normally be exposed to. And as we see over time, the wildfire particulate matter is really a health issue, and that's impacting our people as well. So we really care about this. We want to be prepared for the future, but we are constantly dealing with these crises. No entity can opt out of the effects of climate change. Nobody. Everybody is impacted by it. And as our Secretary of Defense has said, is the department must take bold steps to accelerate adaptation to reduce the adverse impacts of climate change. We must act boldly. It's not an incremental change. We must adapt. We must prepare for, withstand, and avoid these effects in order to carry out our mission. And the other thing about the department that's a little bit different than some other agencies is that we focus on climate adaptation and resilience. And we talk about resilience, we're also talking about climate mitigation. So we kind of match climate adaptation with climate mitigation to get to resilience. If we don't do anything about greenhouse gases, it's just going to continue. The greenhouse gases are going to continue, the air is going to get warmer, and we're going to be facing the same kind of extreme events that we're facing right now. So we feel that greenhouse gas emissions mitigation is very important. And when we talk about adaptation, what we're really talking about here is managing the unavoidable changes that are coming. Remember, there's a very large lag time between climate change and its actual impacts here. So even if we were to turn everything, all the greenhouse gas emissions off to zero tomorrow, there's going to be a couple hundred years of sea level rise coming at us. There's going to be a couple hundred years of changes in atmospheric circulation and in temperature that's going to be impacting us. So those are unavoidable changes, and we need to manage those. But what we really want to do is avoid changes that are unmanageable, right? We want to mitigate climate. We want to reduce greenhouse gases so that we can avoid that to the extent that we can. And what I want to say is that when we consider the Department of Defense, most people say, you know, you're the biggest emitter of greenhouse gases of all federal agencies, and we are. We're the largest greenhouse gas emitter, and yet that's 1% of U.S. greenhouse gas emissions. So we're doing the best we can to change that, but more is needed, and it's not just by the defense sector and the defense industrial base. It's the entire population of the United States to do this. So what are the unmanageable and unavoidable kinds of effects that we see? Well, installations and infrastructure, that's the area that I work. Sea level rise is affecting many of our installations today. You know, with the Navy, most of those are at the coast, right? So almost every single Navy installation is dealing in one way or another with the effects of sea level rise. Training areas, very important to us, especially for those training areas that are at the sea-land interface. And those are being impacted as well by coastal erosion, by other impacts of sea level rise. We're seeing flash floods and erosion. If you paid attention to the news last July, you might have seen that West Point in New York received a very large, heavy, intense precipitation event, over $200 million in a day and a half rainfall event. Our stormwater codes are not up to date. We need to change those stormwater codes to be able to be prepared for these kinds of events in the future. When we're operating, increased insecurity globally leads to increased failed states, which leads to increased requirements for the Department of Defense. We're not looking to expand that mission. We're looking to decrease it or manage that to the point where it can be managed. We're seeing more international humanitarian responses. And these, again, are taking service members away from their job of national security to deal with humanitarian crisis. So if we can reduce greenhouse gases, we can at least help to make the problem a little bit less. And I mentioned defense support to civilian authorities. We do this in the United States every time you see the National Guard at a hurricane or at a fire or at another kind of a natural disaster. Those are service members who are doing defense support to civil authorities. For people and equipment, does the equipment operate in the temperature ranges that it's going to be seeing? Heat stress on training. When we have reports of increased morbidity or mortality due to training, we really need to pay attention to that. You can only lighten your load so much. You can only cool off so fast. We need to increase the innovations that help us operate in those temperatures so that people can perform in those temperatures. So when I think about managing the unavoidable, I'm thinking about our people who are on these hurricane rescue missions. I'm thinking about our service members who are fighting fire on the ground, not just in a plane. I'm thinking about people who are training in flash flood conditions. A number of years ago at Fort Hood, 11 people died when they were training and there was a flash flood. And so now you see the sign here, you know, watch out when the water level rises quickly, don't pass through this area. And then again, in the bottom right, it's the ice storm in Texas a couple years ago. It was the military members that came in and helped the state authorities who were quickly overwhelmed by these kinds of events. When we talk about unavoidable wildfires, up in the upper right, Offutt, Air Force Base in 2019, over $1 billion in damages, and thank goodness they had just moved their strategic communications building because the old one was in the water. In the lower left, it's any number of hurricanes. In the lower right, it's drought, which impacts our installations as well as populations around the world that rely on reliable quantity and quality of water to maintain civility. So the problem is, what happens if the unavoidable becomes the unmanageable? And frankly, at times in the past 5 years, it's really seemed like we've been facing unmanageable changes. Let's kind of highlight a few of these. This one here is, gosh, I can't read anything from here. This is wildfires on Maui, the big wildfires in Maui last year. This was service members that were fighting the wildfires there. National Guard coming to Louisiana for hurricane relief at the same time that they were going to California for fires. Again, people dealing with heat injuries during training, trying to cool people off, so increased need for medical care. Fire season is now year-round for the Guard. And then also part of the innovations of the DoD is they're now using unmanned, uncrewed aircraft now to monitor wildfires. So the Texas wildfires last year, we had a lot of drones in the air just looking at the spread of those. And I think I mentioned it to one of the students earlier, but heat exhaustion and heat stroke with a monthly report on heat effects that we're facing already today. So there's about 100 years of change coming, and here we are today facing these kinds of numbers. And again, a table of different locations. If you're familiar with the military, you notice a lot of training sites here with the very high incidences of illness. So what are some of the unexpected impacts? Clear air turbulence. Were people expecting this? No. Did our climate models tell us that we were going to get clear air turbulence? No. But what does that mean for us? It means that it's going to alter the reliability of flight, not only for us civilians trying to fly around somewhere, but for the military trying to fly. Severe turbulence at typical cruising altitudes are going to be 2 to 3 times more common, and this is going to cover most of the northern hemisphere. Lightning strikes, okay? So lightning strikes impacts our ability to maneuver when we want to maneuver. Lyme disease, again, when you talk about people who are training in the wild areas, Lyme disease and difference of vectors, invasive species moving across the United States, overwintering where they didn't overwinter before, okay? And then in the Arctic and in Siberia, we're seeing zombie fires, or fires that overwinter underground, underneath the snow cover. They're overwintering, and what's that doing? It's thawing permafrost, and when you thaw permafrost, you release methane, and methane has about 80 times the global warming potential of carbon dioxide over a 20-year lifespan. So what we're doing is accelerating the release of methane in a way that's accelerating the greenhouse gases in the atmosphere. So these are some of the unexpected impacts of climate change. And will we recognize that point? Is it going to be many points at which the unavoidable becomes unmanageable, or is it going to be a few? So this was back in 2022. This was kind of alarming. Both of the planet's poles experienced extreme heat at the same time. Both the North Pole and the South Pole were 50 degrees above average temperatures at the same time. That was pretty frightening. That was 2022. Ice sheet losses that we're seeing. Smoke from wildfires damaging the ozone layer. So something, again, that wasn't really expected. The kinds of things that would drive research into understanding some of these more subtle effects or cascading impacts. This is the daily sea surface temperature graphic. The red line is 2023, which broke records. They actually had to add to the y-axis to put on 2024 for the daily sea surface temperatures. So this is something that wasn't really expected anytime in the next 20 or 30 years or so, but it's happening now for reasons that we don't fully understand. But these increases in sea surface temperatures alter the ecology, which leads to fishing collapses, which leads to instability, which leads to the kind of problems that we're trying to avoid in the Department of Defense. So just these kinds of sea surface temperature monitoring that we're looking at. And then on the right, we're looking at the Antarctic sea level extent which is about the second lowest ever, when the lowest being 2023. So the idea that even in Antarctica, we're seeing a decrease in in sea ice extent, which impacts krill and the survival of orcas and whales and other fishes that are needed for the Pacific Ocean, the Southern Pacific Ocean economies. So will we recognize that point? I'm not sure, but if we're not paying attention, we won't see that. So when we think about the past and the future, one of the things we can do is look at average global air temperature records, which you're seeing here. And then what you're also seeing here on this graphic is that by August 2033, we're probably going to reach this 1.C, the infamous 1.C degree average temperature increase. And the fact is that we're already above that in certain places in the globe. So in the Arctic areas, we're already around 3 degrees C, which means they're seeing the effects today that weren't expected for many, many years. And so we need to prepare even faster to be able to operate in that kind of environment. It's the northern sea route expanding. It's the potential for hostile activity in the Arctic. So these kinds of graphics really help us understand, but I think the other thing is the extreme variability of these temperatures. And if we look at the temperature this year, February, and we look out here, you can see that we're actually within, the variability that one would have expected 20, 30 years from now. So this is my thought experiment for people. What I want you to do is think for a second. For those of you who are, say, a little bit older, closer to my age, think about when you were, say, 18. And for the younger people, I want us to think about when you were 12. And if you thought when you were 12, if you put yourself in that position, and you thought about where you'd be today, is this where you thought you'd be doing what you're doing? And if you're closer on my end of the scale, if you were 18 and you thought, what I'm going to do with my life, is this the person you thought you would be doing? Is this the job you thought you would be doing? I want you to think about this because this is really germane to thinking about future conditions. When I was 18, graduating from high school in 1975, I wanted to be an engineer, and they said, well, girls aren't engineers. And then they said, and you have no aptitude, okay? So I never expected to be in the position that I'm in now. But this is just like the future. When we think about future climatic conditions, it's always impacted by not only the boundary conditions around you, but all of the internal decision-making, the conditions that change the trajectory of your life all the way along your pathway. And that's why when we think about climate change future conditions, we need to look at the widest possible range of models. If we're looking at them for decision-making, we need to know what all of those futures are so that we can encompass that. Our equipment will work under those conditions. Our people will function. Our planes will fly. Our boats will be able to move at speed, right? We have to think about that. So if you go back to your 12-year-old self or your 18-year-old self, I'm going to ask Jeff, are you doing what you thought you would be doing at 18? No. Okay.
I was training to be an engineering physics.
There we go.
Yeah, so.
Engineering physics, right? And so I think really the whole point here is that we don't want to limit ourselves to a few highly resolved, carefully laid out future conditions, because every time you see something highly resolved in the future for your climatic conditions, what you're seeing is one possible option with a lot of uncertainty around it. But for the DoD, we need to consider that uncertainty. That's probably the most important factor for us, because it's the uncertainty that drives the changes in the world that we need to be prepared for. So when we think about transitioning from theory to actionable intelligence for decision-making in the Department of Defense, and this is a picture from Maui, from people helping to respond in Maui at Maui fires, what we think about is that people think moving from theory to practice is actually fairly straightforward, and in fact, it's not straightforward, okay? And here's an example. It's a 60-year-old example. It said, a friend of mine once said, there's no difference between theory and practice, but there is a difference, and that difference is practice won't let you forget anything or leave anything out. In theory, problems are easily solved because you can leave something out. You've made assumptions to get where you're going. We're dealing with practice. Every single day we're dealing with practice. We can't make an assumption and then feel safe that that assumption is actually going to be the way things are going to happen. We have to test them. If it's a near-term assumption, we can monitor to see how things work out. But if it's a far-term assumption, we better be ready for a change and be monitoring the world around us to make sure that we're ready for that change. So the other thing about actionable intelligence, or that the kind of information that we act on, so not just a climate model or all the climate models, but how we translate those models into the information that we act on, is we think about it in terms of materiality. And if this comes from the world of finance, where if you are being audited and you have an omission or you've neglected to provide certain information and you make a decision based on that, you will be liable for the results of that decision if you left out material information that was material to the decision that you're making. So that's really important to us, and that means that the climate projection information that we pay attention to, for where emissions or selection bias could come into play, could make us, lead us to a decision that isn't actually a decision that's important to us. So the baseline here is, if I had different information, would I have made a different decision? And that's exactly what we have to pay attention to all the time. So we fund a lot of academic studies that may look really in depth into one or two climate models, and just and then look at them and do some interventions and see how they happen. But we're not expecting to use that for a decision. What we want to know about is all of the models, all of those little internal pivot points that might lead to a different outcome than we expected. We have to be ready for that outcome. And so when we consider DoD decisions, we're really considering them across a time-space continuum. But for time, we're thinking about amphibious assaults. What's the weather? I'm going to go to my Air Force weather, my Navy METOC people, right? What is the weather impacting me? If I'm planning an exercise, maybe it's 120 days off. That's still pretty much weather, or it's climate-impacted weather. If I'm looking at the budget, which everybody needs to pay attention to, I'm looking about 5 years out on that budget, okay? And that's still climate-impacted weather and weather-impacted climate. If I'm looking at war games, where I'm just testing some of these theories that I might run into in the real world, I'm looking at 10 to 20 years, and here I'm starting to get more to the climate-changed future that I need to pay attention to. And then out past here into infrastructure, into retrofits, into buildings, into decarbonization, then I'm definitely in the world of climate projections, and that's what I'm paying attention to. So this is part of what we have in our climate adaptation plan. We're paying attention to this weather to climate continuum timeline. But the bottom line up front, which is actually not up front in this chart set, for the Department of Defense, is climate change amplifies operational demands. We already know that here. It degrades our installations, right? We need those installations as force projection platforms, as power projection platforms. We need them because they're the place where our service members live. They need to be healthy for them. They need to be safe and healthy where they live. And it addresses climate resilience, also addresses energy resilience and water resilience, because both energy and water are required to function. That means we pay a lot of attention to our energy conservation, our carbon-free energy, our decarbonization of buildings, our water conservation, our alternative water sources. We pay attention to the vulnerability of our water sources to be resilient to both of those things. But it's adaptation and mitigation together that we need to pay attention to. We can't do adaptation only. We must do mitigation as well. So when we think about climate resilience in the DoD, it's guided by strategy and policy, just like everything else in a large hierarchical organization. We have the DoD Climate Adaptation Plan, which is listed here, that is to make sure that we can operate under changing climate conditions. And we have the policy, the DoD Climate Risk Analysis, which says that we will integrate these climate into all the decision-making that we make, along with all the other factors that influence us. And again, resilience is the ability to anticipate, prepare for, and adapt to changing conditions and withstand, respond to, and recover from disruptions. And then here are some of the documents that we're looking at. And I will say that our Climate Adaptation Plan initially dates back to 2014. So we're putting out a new edition this year the 2024 to 2027 plan, but we take it very seriously. We have to. We're investing the taxpayers' money. We have to do it right. We have a duty to do that. And we have enough information to adapt now. We don't need to wait for perfect information. It's just like in a battlefield situation, you can't necessarily wait for perfect information. You have to go with what you have and, hedging your bets, understanding what the uncertainties might be in front of you. But we can adapt to, now, and we are beginning to work on that in the Department of Defense. So again, it's managing unavoidable impacts, and we have basically three tough choices facing us. We're going to adapt or defend in place for our installations. We're going to change the mission at those locations that are exposed to and vulnerable to climate. Or we're going to relocate all or part of a location that is very exposed to climate, which prevents us from carrying out the mission that we need to carry out. And we can look at these in very sophisticated ways, as you can see in our skanky diagram here. But basically it is, are we going to make the tough choices now in order to be prepared? It takes for infrastructure 25 to 30 years between a conceptual design, through authorization by Congress, through appropriation by Congress, through engineering, through construction, to operation. That's a long time frame, so we need to start now. And again, energy, it's critical to what we do. Operational energy is about 77% of the department's energy budget. Operational energy for the platforms that we use. And it's absolutely critical. So we've been working very hard on trying to decrease that, just as we've decreased our installation energy use about 30% since 2008. We're working to decrease our operational energy use. And to do so, it helps us protect our performance and avoid disruptions in supply chain. The idea here is that contested environments are not the place that you want to be having a long line of fuel trucks snaking along, because they're a sitting target for everybody. And so the idea here is when you can find alternate energy sources and uses, you'll be able to improve our effectiveness in contested environments and our safety. And when we, GHG emissions reductions enhance operational flexibility at the same time. So we're working really hard on that, and we have an entire innovations group that's just paying attention to operational energy capability improvements. So I guess the top line messages that we have in the DoD are climate change continues to increase the demand for military operations. It's not going away, both at home and around the world. We have been forced to absorb billions of dollars in damages at our installations due to extreme weather and climate events over the past 10 years alone. Things like Tyndall Air Force Base after Hurricane Michael, Camp Lejeune after Hurricane Florence, Tyndall after flooding on the Missouri and Platte Rivers. Just the West Point event, over $200 million of damage in one rainfall. Typhoon Maiwar in Guam just last year, over $3 billion and counting. And basically the entire island is in a very strategic area of the world is impacted. So climate adaptation efforts must align with and support the warfighting requirements. Everything supports the warfighting requirements. Meeting these national defense requirements are the highest priority. Our climate adaptation plan informs these requirements, making sure that we're considering climate all the way along the supply chain, the acquisition and supply chain, right into operations. And the financial consequences of failing to adapt compound over time. It's going to be more and more expensive if we don't prepare adequately for this. And it's lost military capability. It's those people who are impacted by wildfire particulates when they're responding to a wildfire rather than doing their typical reserve training. It's lost military capability, weakened alliances, weakened international stature, degraded infrastructure both inside our fence line and outside our fence line, and missed opportunities for technical innovations. We have such innovative people in America. We need to put them to work, and we need to support them adequately to come up with the kinds of technological innovations we need to reduce greenhouse gas emissions. So I think that's my last slide. Yep. Did okay on time?
That was perfect. Thank you
Okay.
so much.
So
You can sit or stay up there, whatever you
I'll
prefer. So I'm going to open the floor to questions, but I wanted to just kick things off with a question of my own. But I first, even before that, wanted to just highlight something that was in the second bullet point of your last slide there. I think this point just, it deserves reiteration, right? That the DoD has been forced to absorb costs because we're not doing enough to mitigate on climate change. And presumably those costs, whatever we've absorbed already, those costs are going to get larger into the future. And so that trade-off between mitigation and adaptation just should be sort of on the forefront of policymakers' minds, and not just the policymakers in the Pentagon, but the policymakers sort of in Washington and other capitals around the world. The question I wanted to ask you, and then I'm going to turn to the floor, the question I wanted to ask you is, we sit right now kind of at the interface between civilian and military dialogue here. And we know that historically there has been a lot of benefit in innovation going in both directions, right? So the civilian economy has got the internet and M&Ms and a whole lot of other things from military innovation, and vice versa, right? Is there more that we can do on sort of both sides of that divide to promote innovation flows between each other? And for instance, I'm thinking about all of the things that the military might have learned about, adaptation solutions, management techniques, rapid response, that the civilian side of our country ought to be absorbing from the military, and how to facilitate that kind of learning.
Right. Well, actually, that's kind of a really important factor. So one of the things I highlighted throughout this is our National Guard and our reserve forces who are interacting on behalf of defense support to civilian authorities. So our service members are already working with civilians all of the time in these national disaster responses. We work with all the other agencies in wildfire, and we lead the nation in wildfire management because our installations are so large. We have 27 million acres, and also we use live fire in our training. So we cause fires, but we also manage for fires to put those out. So we're able, in a way, to kind of lead with the wildfire management. But I think that we could do, and we welcome suggestions for improvements that could go both ways in this, from military to civilian. I think one of the things that I've noticed over the past 20 years or so is that there's a lack of understanding on the part of people about natural events, extreme weather events, wildfire, flooding. They don't really understand these kinds of events, and they think that if it's happened once, it might not happen again for a long time for me. But in fact, these events can happen frequently and over, even though they're a rare event. And every time you get an extreme event, you're actually increasing the chance that you're going to get that same magnitude of event again, because the frequency is always changing with extreme events. So I think maybe it's education about the role of extreme events in our lives, in our infrastructure. It's recognizing things like the stormwater codes are outdated and need to be updated. So when you're driving down a road on a heavy rainfall and the road is flooded, that stormwater has not been properly, stormwater management system hasn't been designed properly. If you're driving along a road along the coastline on a king tide and the road is flooded at the high tide, then we're not accounting for sea level rise in that road. People seem mystified by this, and as an engineer, to me, it's kind of the bread and butter, right? It's what I think about all the time. But if we could communicate that better, so that people understood that they might be investing in an unsafe place themselves, personally, their home. If they understood better, maybe we would reduce some of the damages.
Yeah. If any of you have, and we were talking earlier about the floods in Dubai recently,
Yeah.
and everybody's seen the pictures out of there just in the last couple of weeks. I mean, it's a very stark illustration of what different places around the world are going to experience, including some here. But let me turn to some questions. And so, Lyle, if you want to kick us off, that'd be great.
Yeah, hi. I'm not sure. Turn it on. Hi.
Yeah, there you go.
All right. Well, thanks very much, Dr. White, for coming to visit. Very interesting presentation. I had a couple of questions for you. One, it seems to me one slide I missed. I don't know if you had it, but what about DoD total emissions? I mean, I'm going to guess they continue to spiral upward. You know, op tempo is
Actually?
Well, okay.
Okay, that's
Wait,
actually.
wait, I have another question.
Okay.
Second question, maybe harder, is, you know, what about our global footprint? It's pretty large. I think we have, what, 800 bases overseas or whatnot. I mean, that has to be part of this equation, doesn't it? And are we, does your office get involved at all in kind of evaluating the environmental costs of I mean, we're just getting kicked out of Niger. We ended after 20 years our intervention in Afghanistan. I'm imagining to keep forces supplied in the middle of Afghanistan, that's a pretty big carbon footprint. I don't know, can you comment on, does your office have any cut on strategy and force deployments, especially our global footprint?
Right. So first of all, my office is energy resilience and optimization. So we have the operational and installation energy for the Department of Defense, and we have the climate resilience and the water resilience, and we also have the innovations program. So the the tech transfer level programs, not basic research, but the ones that are getting put into practice to actually reduce those operational energy loads. Our DoD total emissions are on a slight downward trend, and partly that's because of operationally we're not flying in Afghanistan and other places like that, but also because our installations have become so much more efficient. So every drop in installation energy, in a sense, masks an operational energy gallon of fossil fuel that's used. We've moved towards renewables. We've moved towards carbon-free electricity purchases on the grid. We have moved towards geothermal, not just solar, but geothermal. We have R&D that's looking at other forms of renewable energies. We're deep into battery electric storage because it's a very quick online replacement for generators, and it's clean for diesel fuel generators. So we're working to decrease that climate footprint. We are global. We have about 600,000 buildings. We have 27 million acres, as I said, in the U.S. We have about 5,000 locations because sometimes it's an installation but then an associated site with that installation. So about 5,000 of those locations. And yet these are located where they are for reasons of national security. And every so many years, we undergo a process called base realignment and closure, and it's a very highly political process, right? A politician does not want to see an installation leave because they see that they're losing potentially jobs or people who are living, about 70% of our members live off base, so they think they're losing some population that would be shopping or buying new cars or renting. So it's not a simple cut back the location and save the greenhouse gas carbon footprint, but we are trying to reduce our carbon footprint. We published last June a plan to reduce greenhouse gas emissions in the Department of Defense, and we started that with our installation energy and our operational energy. Those are the two big ways to cut. We're working with blended wing bodies in the Air Force to increase the efficiency of flying. We're looking at other ways to increase the efficiency of our platforms. For our vessels, we're looking at different ways of cooling them so that on higher sea surface temperatures they can retain maneuverability while using less fuel. And so it's really like looking for the efficiencies everywhere we can that we're doing that. But I do want to reiterate that even if we are the largest agency producer of greenhouse gases in the U.S., we're still about 1%. We're only producing 1% of what the U.S. produces. So it's a difficult question, and yet.
Can I just add, actually, I mean, the point about the 600 bases around the world, 800, whatever the right number is, this, and to your point about the U.S. military being 1% of the U.S. total, again, like to the extent that these bases operate as mini laboratories about how we can do better, how we can set up microgrids, how can we ramp down the emissions from military bases, and then apply those lessons, not just within the military, but to the rest of the economy. I mean, the 99% is what we need to also address as well.
Right.
And so taking those lessons out of the military and applying across is super valuable.
Yep, that's actually a really good point. I mean, one of the things that the administration has pointed out is it wants federal agencies to kind of send a market signal, right? So as the department moves towards zero-emission vehicles for non-tactical vehicles, that's sending a market signal. It's not as big as a market signal of many Americans buying electric vehicles, but it is a signal. In fact, this year we weren't able to buy all the ones we had contracted because they went commercial. They were sold at a higher price commercially. So it is beginning to send some kind of a market signal. And those innovations do translate
Yeah,
to the civilian population.
thanks. I think I see a question at the back.
Hi, thank you for your talk.
Would you give your name, please?
Yeah, it's Catherine. I'm interested in the topic of drought and was wondering if you could say more about that, where, how much, how soon, and what that looks like in general.
Well, drought is here, and it's actually everywhere. So, 10 years ago, what people said in climate is that the wet get wetter and the dry get drier. But what we've actually seen is that everybody gets wetter and drier, right? So what we're seeing, even in the literature over 10 years, we've seen movement towards the term flash drought because of increasing air temperatures and increasing aridity. What we're seeing is that the intensity of drought increases much faster. So we can't actually have enough time to prepare for those droughts as we did in the past. So we've really shortened the amount of time to go into drought, and those droughts are more severe and they're lasting longer. So drought is a major issue facing the American public, all nations actually, but particularly the American public in the Southwest, but not just the Southwest, the Southeast. The Northeast has even been seeing droughts for short periods of time, and if you follow the National Drought Monitor from the National Integrated Drought Information System, NIDIS, when you can start to track those droughts over time, and you'll see how much of America is in drought at any given time. What it's doing is impacting the availability and quality of the water that we drink, right? And so the big thing in the news has been the Colorado River over the past number of years, which really supplies a lot of water to the west. And the Colorado River has been oversubscribed. The allocation plans were designed for a wetter earth than we're seeing right now. And so that's resulting in restrictions on water. And what we're doing in the Department of Defense is mapping those drought areas. We're looking for ways to monitor so that we're prepared for drought. And we're looking at ways to conserve water on our installations and to use alternative water sources, manufactured water sources, and to make sure that we're not relying on a single source, say a Colorado River source that might be cut off.
Thanks so much for that question. And just to add to the consequences of it, right? Drought is very often going to be linked to power systems. Electrical generation almost always relies on a coolant system, which is usually a river or a lake. When those dry up, guess what? We have an energy system crisis as well. And you see this in Europe last summer where I think it was 56 nuclear reactors in France had to be shut down, some of them for other reasons, but mainly because the rivers ran dry, and they just didn't have a coolant available. So,
yeah, that's a huge problem here in the U.S. too.
So we have these sort of cascading issues. Steve, yeah.
Thank you. Thanks for coming to Brown today. Steve Gurenz, from Director of Government Relations at Brown. And to one of your earlier points about engaging with the Department of Defense, one of the things that Brown is looking to do more of, I should say just a few faculty, but with ERDIT, Engineer Research
Development
Centers, right, exactly, on some of the hydraulic modeling. And we'd just love to get your thoughts on how university research institutions like Brown can engage with the Department of Defense on research related to modeling, if it's through Muri or even Minerva or whatnot.
Right, thanks. So I actually was mentioning this earlier to Jeff, was that so when we think about research, we think about it in terms of basic and applied, or we think of technology readiness level, TRL. So if I'm thinking of Minerva, that's more in the basic research TRL, say 6.1, right? So in our group, the innovations group, which are, we have two major kind of applied in modeling the situations that you're talking about, would be the Strategic Environmental Research and Development Program, SERDP, and then the Environmental Security Technology Certification Program, ESTCP. And between them, they have about $150 million a year in R&D, and that's competed. And that SERDP has a federal advisory committee that oversees it, but the ESTCP is made up of interagency groups that sit on a technical committee overseeing both the development of the statements of need and then again looking at the proposals against those statements of need. They're competitively funded, and then also overseeing them with intermediate program reviews while they're being run to make sure they're going in the right direction. So those are the two programs that I would say for modeling kinds of things. They're just like NSF. They encourage collaborative efforts. They're looking for, what the Department of Defense is looking for is people who are working with each other. What we don't want is siloed, develop expertise in one area only with one faculty member only. We want to see a wide range of people working together because that's where we're going to see interdisciplinary solutions that generally are more likely to have a better than incremental improvement in innovations, right? If it's all the people are thinking in a aligned manner, we're just going to see incremental changes. So those are the two programs, and those are, you can find them online, and they have differing periods of time for the calls for proposals for the regular program, and then we have special calls. But right now we're doing a lot of work on coastal modeling of Pacific Islands, for example, and we are using some of the ERDIC people too, as well as USGS, NOAA, NASA, and other agency experts, and Princeton, gosh, let me think of all the, Princeton, some universities in Florida. Basically, where the expertise is, we want to tap into that. And we want also to form networks of people who can work together to help us solve these tough problems.
I'm trying to write down the acronyms, but anyway, I'll get those later.
I think Melissa.
Yeah. Other questions from any of our students? Yeah, Matthias, please.
Well, I have a question in that case. So climate change influences the U.S.'s military capacities, which has implications for the U.S. military strategy. But a perhaps more fundamental issue in U.S. military strategy is the relative power between the U.S. and other countries. So other countries are also impacted by climate change in the military capacity, say less seawater ice around the North Pole increases the Russian Navy's capacity, more heat and drought in the Middle East decreases Iran's military capacity. I wonder how these climate change impacts on other countries' military capacities influence the U.S. military strategy.
So there's actually a whole range of documents that would be useful to look at. Definitely the National Intelligence Estimate is one of them. It's put out every year, and it really talks about exactly those kinds of issues. I mean, not just climate, but climate is one of the many issues that impact them. The National Security Strategy, the National Defense Strategy. So those are kind of the big three in terms of strategy documents in thinking about how military power is changed by changing environmental conditions. If you look at how we do joint planning and the joint planning manuals, they really look at environmental conditions as one of many factors that impact military power. And those factors, they're interesting in the way that they leave the environmental to be the loosest, because they know that there are so many ways that it can vary in an unexpected way, and that's why I tried to focus here a little bit on the unexpected things that we're seeing in climate change now, like the sea surface temperatures, which we weren't really expecting to see for quite a while. How those will impact military power, I'm sure there are people studying them who work for the NIE and work on the NSS and the NDS and the intelligence community, right? What we're concerned about, where I am with acquisition and sustainment, is making sure that we can operate in those conditions.
Maybe worth pointing out that we at Watson will have Avril Haines, the former National Director of Intelligence,
There you go.
For an event May 1st, I think, 4 p.m. So, yeah, and be there to ask the climate question, I think, is exactly what we want.
Yeah.
So, any other questions? Yeah, please. think we'll take one more and then we'll probably wrap up.
Good afternoon, ma'am. Brian Hass, I'm one of the Watson Military Fellows, got up here a little bit late on the Navy side, representative. So I have maybe another hard question
Okay.
for you regarding the fight against these incremental changes that you discussed. And the current administration has a pretty different policy than the previous administration. Can you maybe help qualify some of the challenges that you faced with the new administration coming in, after the previous administration, and then maybe some of the risks that you see and challenges that you're preparing for during an election year when the next administration may or may not have some of the same urgency with these climate initiatives and the project management issues that you guys are working on?
Right. Well, I think the strongest thing in our favor is that climate change support in the Armed Services Committees is bipartisan. If you listen to the hearings last Tuesday, and if you go back and look at them online, what you'll see is bipartisan approach to supporting the Department of Defense to be ready for changing climate. It is no surprise to the committees because they are the ones that approve the military construction bills and the National Disaster Recovery Acts that fund recovery from these events. So these committees truly understand the need, and even if someone were to maybe make a media spot somewhere, and I'm not saying our committees are doing it, but if a representative were to do that, generally when it comes to defense, they're really they're wanting to make sure that we can still operate. I don't think they want to hamstring defense, and in my career, I haven't seen that happen. So I think what we try to do is to provide the best return on the investment for the work that we're doing. We try to communicate the value of that work. We work hand in hand with our innovations groups in my office to make sure that we're actually fielding techniques that will reduce our reliance on fossil fuels, will improve our efficiency in contested environments, and will improve the safety of our people overall, whether they're in a contested environment or whether they're on an installation. So I think these are hard investments to argue against. So perhaps we're not in the same position as maybe other agencies who might have a little more movement between administrations.
It's a great question. I don't want to in any way weigh in on this from the military side, but I do notice, with the national security strategies, if you compare the current administration's one, there's a lot of climate content in that. In the previous one, there was zero climate content. And so elections have consequences, right? I mean, on the political level, that's absolutely right. At the top level, that's going to, these things do matter for sure. And so happily, I think Dr. White is quite right that on the operations level, it's a little, there's more consistency.
More consistency, right. And I think that gets back to the point of, again, communications, the people, the constituents don't quite understand these changes, right? And if they were communicated in a way for them to understand, maybe they'd be coming back and saying, this is affecting me. My insurance is going up. I'm not able to get wildfire insurance. I'm not able to get reasonably cost flood insurance. My roadway was closed. I lost my power for 10 days. If they start to realize that these things are connected, then perhaps maybe the conversation would be different nationally.
Well, on a slightly happier note, I understand that we have some refreshments just outside, and so I wonder whether you would please join me in thanking Dr. White for coming to Brown.
Thank you.